Hello, and welcome to the Unnamed Reverse Engineering Podcast. I'm Jen Castillo. And
I'm Alvaro.
Hey there, Alvaro. How are you doing?
I'm doing well, thank you.
You said you weren't going to laugh. And I'm really excited today because we have Jiska with us, and we're going to talk about wireless hacking and wireless engineering. Welcome.
Hi, I'm Jiska, and awesome to be here. I work at the university at the Secure Mobile Networking Lab at TU Darmstadt. So I can talk pretty freely about the stuff that I'm doing because it's going to be published regularly in papers, talks, etc. So I can also talk a lot about the reverse engineering things that I did.
That's awesome.
Yeah, I love the fact that you openly state, yes, we could talk about anything. Because sometimes I have to say, not always, but we do have some guests that we have to tap dance around some topics.
Yeah.
And how what verbs we use.
Yeah, I can't say names of things or people or companies. So this is refreshing.
Can't spoil movies. There's a whole list of things we can't do.
Well, the movie spoiling, we have spoiled them already, so it's fine. I've given up that one. Thank you so much for joining us. I guess we can start with, how did you end up here? How did you get started with reverse engineering?
So I didn't do like the classic path of learning how to reverse engineer, but I randomly reverse engineered something many years later. Like the first time I stared at some assembly was back in school, because I was at technical school where we also did some ATC51 assembly programming. So I had to do this as school exercise. And I even programmed DCF77 receivers. So that's a signal that you have for your digital watch to get the time. So I did assembly programming. I did like very basic signal programming back in school. And then I did like a bachelor, master, lots of boring things that didn't really connect in some sense. And like had all these things, like I had to program, I don't know, Visual Prolog. You probably like never heard of Visual Prolog, but it's like super weird stuff. And you learn it and you never get to use it again. And then later on, I decided to do a PhD, and still I just did like wireless things. And then suddenly we had this fitness tracker, a Fitbit. And it was in another group, and they said like, this thing does, I don't know, signals, Bluetooth, something. Can you guys help us? And I was like, yeah, okay, we can like have a look at this. And so suddenly I found myself reverse engineering a Fitbit firmware, which is a bare metal ARM firmware, because like they had other people who knew how to reverse engineer. I didn't, but all the people experienced with reverse engineering did not really have time. So the first thing I looked into was a bare metal ARM firmware with Bluetooth handlers for updating firmware. Like that was the thing I was interested in.
Yeah.
As a starter project. Yeah.
What tools were you using for that back then?
So the good thing is that even in our group, we had some people with reverse engineering background. So we had like IDA and stuff. So Ghidra was not out back then. That was like around 2017, I think. But yeah, so I had access to some slightly outdated IDA. So because I mean, we are university, we have like security projects, and then every now and then we buy some IDA license. So not too bad. But still, I mean, for bare metal firmware, there's not much that IDA helps you.
So I think going even further back to answering this question, you said random. Like none of that sounds random. That just sounds like standard university stuff. Like it doesn't quite fit together until you kind of get to the end where you're like, oh, now I have a project. Oh, I have these skills I can pick up and add. So 2017 is kind of later in the Fitbit. The product itself is a lot more mature than maybe it was back in 2010 or 11 when it first came out. And I think the other thing that I find interesting is I think by then, maybe Alvaro, you remember this, was the other show, the Embedded FM show, had they stopped working for Fitbit by then?
It depends who you ask. No, but yeah, we know a lot of the people who worked on it probably, which is really fun. So some of the people I'm working with and where I currently work, they're for another company, but they all are ex-Fitbit firmware. So I'm really curious to hear how it all went.
Yeah, I mean, it's awesome. If you manage to hack like the firmware on such a thing, you have access to a lot of different sensors. And yeah, usually, I mean, there are like dev kits and stuff that have sensors, but in a Fitbit, you can get it in a very small form factor. So as soon as you can like reprogram the firmware, you can repurpose it for all kinds of things. And meanwhile, in the Fitbit Ionic, like the next model, they have some development kit to get some of the values. And I think also for Apple Watch, meanwhile, this exists, but still like really reprogramming the hardware, you cannot do this.
Yeah. Yeah. No, I mean, especially with the bigger company. I see a cat. Especially for the bigger companies. Yeah. They're not the most developer friendly, at least for the low level, right? They'll give you all this high level API, like, oh yeah, call this function to get the thing. But like, I guess, yeah, I guess we'll get to it, but you're more interested in the low level access.
Exactly.
So let's go back to that Fitbit. What did you find? How would you describe the hardware and the firmware and what you realized about it?
So, I mean, it was my first project and I didn't have that much background in how such a thing is structured. But I had a colleague who did some stuff with Wi-Fi reverse engineering and he helped me to start with this. So back then, like, yes, I knew assembly, but not ARM assembly. And I tried to look for certain things, like the crypto algorithm being used, because I knew that would also be relevant for the update. Certain bit and byte sequences from the protocol. So this was the stuff that I looked into. And like much later on, I learned like, okay, it's ARM. So you have like in the beginning, like the vectors for the interrupts and stuff. So that's stuff I didn't knew back then, but also was not that relevant for the project because I was like really looking only for the protocol implementation.
Are these Cortex M's or Cortex A's by any chance?
I think Cortex M, like STM something.
Oh, cool. Yeah. That's where I live right now. So I'm a fan.
in the M streets.
In specifically the STM32 M
Is
stuff.
Is the F series or
well, F series, L series. Yeah. That's my jam.
Yeah,
That's
awesome.
And I assume they had a separate Bluetooth module?
Yeah, it has like an NRF module. So it was not really hacking Bluetooth back then. It was just like how they programmed the protocol handlers that then were actually being handled by the NRF.
Was it using Nordic's standard protocol to basically write data across to it?
Yeah, like BLE GATT. So like attribute protocol where you have certain like handlers that accept certain format of data and also confirm that the data is being written, etc. But only, I think, in 20 byte chunks or something. So the firmware update also is super slow when you do it over BLE GATT and acknowledge like each frame. So the update would take several minutes.
Yeah. Yeah. But I mean, I guess hey, everyone's been learning how to do more efficient upgrades or over the air updates over time, I guess. But yeah, no.
Is it learning or adding actual security and
security, but also just the like, oh, maybe we don't hack every single thing, right? Maybe we send longer buffers and yeah, previous companies, it was the same deal.
Oh, you mean get like a larger MTU?
Yeah.
For that, yeah.
But even like the Fitbit Ionic has a compatibility mode where it would not get the update over Wi-Fi because it has Wi-Fi, but like BLE GATT. And since it's a smartwatch with like a user interface, much more features, the update over BLE GATT would take like, I think, half an hour.
Oh, because the firmware is just that much bigger.
Yeah.
Wow, I can't even fathom that it taking that long. I guess that's where you end up with two different strategies, where either people decide to tell you, "Hey, we're going to do an update," And they only do that if they know that they can do it within a short amount of time where it's not too much of an inconvenience.
Mm-hmm.
Or they end up doing like a background one when you're charging or something like that. Because they know it's
Yeah,
going to
but
take half an hour.
you can't for BLE like, because that's the thing. It's implemented in the application, in the smartphone app.
Uh-huh.
And it needs to be in the foreground. It cannot be like in background.
Oh, no.
So you have to have the app open.
I think it depends on what platform you have, but I can tell you could do it in
think
background.
it's on iOS.
If you're on Android, I can tell you could definitely do it on background.
Oh, iOS, it's foreground, I think. Unless, so I mean, in the iOS universe, there's like a ton of things that just update silently. So if you have like AirPods or something connected or an AirTag, they would just, as soon as they get connected and as there is an update, they would just update themselves.
Yeah, and I forget, but iOS apps like I don't know what the name is, but you can ask for different permissions or allowances from the OS to be able to run in the background or do certain things. So maybe now there's one, but
might be.
Certainly wasn't one back then.
But there's other things that you can do. There's all kinds of shenanigans you can do on iOS to like with your wearable to get access to stuff that you wouldn't be able to get access otherwise in your app. Like,
well, I'm
app
really
to app
curious
you
to
can't
hear.
do it, but if you pass it through your wearable, you can get the access.
Because I think we're going to cover a little bit of this later, right?
Yeah. Let's not blow our wad here.
But maybe it's something funny for the Fitbit stuff. So, like, I finally figured out how to update the firmware, but it was my first reverse engineering project, so I still didn't know, like, what should I change now? I mean, like, doing something to the sensors is, like, really, really complicated. And Daniel, so the colleague who also worked with me on this, and me, we were having a 34C3 presentation on all of this. But we were like, okay, we need to make a cool demo for it that we can modify the firmware. And it was like at the event, at the speaker table, like in the speaker room, very, very short before the actual presentation, we had the idea to increase the step counter. So he just made a very small change. So basically, whenever it would do like a get steps function, then it would return steps times 100.
Oh,
and
nice.
Like at the speaker room, like a few hours, I think, before the presentation, we just made this video where we were shaking a Fitbit, and with each shake, the steps would increase by 100.
Wow.
Yeah. And that people might think like, oh, whatever, but there's actual companies or insurance that actually encourages people to go walking and stuff. Like, this is not something
that is the basis of what their premium costs are, like, at least in America.
Or sometimes they give you prizes, like you might win a prize for walking the most, right?
Well, there's also all of those company health benefit,
like challenges or whatever.
Health challenges,
yeah. And back then they would just trust the Fitbit, and so the high numbers without any validation, if a human being could run so many steps in a minute, it was just uploaded.
So did you add a random number between 0 and 100 to make sure the step count wasn't a multiple of 100?
Was it so obvious?
It was really obvious. And even worse, if you would reset the Fitbit in a certain state, and then would be times 100 times 100. So really, really high numbers, and the server was still accepting this back then. I mean,
because this gets uploaded.
Yeah, it's always uploaded. So back then there were no checks. I think now there is checks, but it was also funny because I had this test Fitbit account, and then I got all the mails within 1 hour, you got the so-and-so and the so-and-so and the so-and-so patch. I was like, oh, funny.
You're nice. the person that walks the most in your country. Like, what?
Yeah. Is there a badge for that?
Probably.
Yes.
Or there probably was.
I think there's something like a New Zealand badge or something when you walk the distance of crossing all of New Zealand, etc. And you just get these badges also via mail.
Yeah.
So I don't want to spoil anything. I don't want to necessarily jump the gun, but is that something is there a spoiler or end to that, meaning other than that Fitbit is kind of put in a blocker on that, or at least a check on that, is there I don't know how do I put this.
Like, do they validate now?
Yeah, no, it's obvious that they're going to validate, but is there any other way that you can easily, like, are there other things that you were able to change or to modify in there?
So, I mean, what they had back then is that the fitness tracker, if you got them from factory, they were communicating in plain text. And then they had a pre-installed key, which was like different for each Fitbit.
Yep.
And they would try to talk to the server. And once the encryption with the server end-to-end encrypted worked, they would switch to encryption. So they had like some encryption trial mode. And
Yep.
back then it was possible to like force them like back into a state where they would talk plain text if the encrypted communication would fail, etc. And this is stuff that they fixed meanwhile. So also each Fitbit that you get from them from factory is already communicating encrypted, end-to-end encrypted, etc. So it got much harder to get into this communication and disable encryption, etc. So there is a lot of improvement for this. It really means that there is no other chance than opening a Fitbit to modify this. And I'm also not sure, like back then they had debug pins that were working and enabled.
Yeah.
But if they would roll out an update where these debug pins are disabled suddenly, then like going back to a version, it would really be hard.
Yeah.
Yeah. Was it just the SWD, like JTAG pins that were?
Yeah, just as
Oh,
WD.
nice.
Yeah. So you could just like dump the whole firmware from the flash.
Did you ever go ahead and start doing any reverse engineering on the Nordic Bluetooth chip?
No, actually not.
Okay.
Well, the library should be public, right? I guess.
Yeah, I think that like that particular piece of software probably right off the shelf.
That's actually, I was a past guest. Shoot, I forget who it was, but somebody posted that they're doing kind of the function signatures for all these standard libraries for Linux and stuff for Ghidra. And I wonder if anyone's done that for all the Nordic libraries, because I'm sure they're everywhere.
Oh man,
like soft device.
There's got to be someone who has, because like that people using that chip in that mode, like there was that teardown that I did at another conference. The NIM, that wristband that uses your heartbeat as the security lock signature for yourself. They were doing that too with that Nordic chip.
I mean, maybe that's like a jump forward. So I, on my own, didn't do like NRF reversing, but the AirTag from Apple, it has an NRF. And Stack Smashing glitch that extracted the firmware from the NRF and did more reverse engineering on the handlers, etc. So that's something that we are going to talk about at Hardware I/O. But I didn't do the NRF part there. So yeah. So it's still true that I never reverse engineered NRF.
Okay, but we had a question. I guess the follow-on question that we had was, how did you become interested in Bluetooth? And it sounds like you already
still a lot of steps in between. I did this Fitbit project, but more like a bit randomly because I wanted to look into the Bluetooth communication. Then suddenly I found myself like opening IDA, and I had a colleague who worked on Nexmon. So Nexmon is a project for Wi-Fi monitoring on the Nexus 5, Google Nexus 5 smartphone to enable the monitor mode. And so this was the initial project idea. So it's like Nexmon for Nexus monitor or Wi-Fi monitor. And later on, he was like, okay, now we can monitor Wi-Fi. What can we do with other firmware? So he started looking into basebands, into Bluetooth, and a couple of other things. And I mean, he did a PhD, and when he was finished, he left our team. But he still had like these projects that he started and didn't finish. And one of these was Broadcom Bluetooth. And he had a student working on this. So Dennis was working on this back then as a master thesis, like already half finished, but he needed someone to finish supervising this thesis, and he needed to like finish writing the thesis, finish doing the research, etc. And Fitbit was pretty close to the Bluetooth firmware from Broadcom. I mean, it was both ARM. It had to do with wireless and with Bluetooth. So I was suddenly supervising Dennis just because Matthias had left the team. And so suddenly yet another topic, yet another thing, yet another project. And of course, you let the student work on everything, right? So Dennis was building a project that he then called Internal Blue. So this is the Bluetooth firmware project that we have. Not Eternal Blue, but Internal Blue. So...
and why Eternal Blue?
Why that's an NSA leaked tools, right?
Yeah, and then it was like a word pun, the Internal Blue versus Eternal Blue. But I'm not sure if it was like the best name idea ever, because now people confuse it a bit. But I mean, I still like the name. It's just people confuse it.
Yeah, I'm just about finished with reading the book Sandworm, and they cover a lot of this, like NotPetya and like all these things. And Eternal Blue's definitely in there. Eternal, I should say eternal instead of internal.
Yeah.
Okay, yeah, that's harder. Reading it is not as bad.
Yeah. So basically, we then had a project to modify Broadcom Bluetooth firmware, and I mean, Dennis did all of this for his thesis. But what I like to do when I supervise a student is, especially when it's like a cool project, I try to modify it or get into it. So I try to extend it. So he built it for the Nexus 5, and I was, okay, let me just extend it to the Nexus 6P.
Mm-hmm.
And actually, this was like a very, very bad choice. So, I mean, you never know it, but like sometimes there is good devices, sometimes there's bad devices to port something to. And actually the Broadcom firmware, the Bluetooth firmware has a handler where you can just say launch RAM and an address. So you can say execute the code at this address, and you can also have write RAM, and RAM is executable. So you can...
That's dangerous.
You just write something to a RAM address and you execute it. So it has code execution already by design.
So that was probably the chief thing that you thought felt like was a challenge, I guess, or was just like a kind of like a misstep in the architecture itself.
No, I mean, it's by design. It's how they change how they update the firmware. Like most of the firmware is like in ROM, and a few changes you can make in RAM. I can explain later, but like for porting, I thought like, okay, cool, the Nexus 6P, it has like the same handlers. So the Broadcom Bluetooth firmware is on a ROM of an ARM chip, and the ROM cannot be modified. So let's say all of the Bluetooth firmware is in the ROM. It's a functioning Bluetooth firmware, but as soon as you have like, I don't know, you connect instead of to loudspeaker, you connect to, I don't know, for tethering to your laptop or something. And then suddenly in production, you see that these two devices have difficulties, or I don't know, performance is not good or something. So you want to patch this. So a Bluetooth firmware, like even if it's in ROM, even if it's well tested, there might be things like in the field that you see they are not working. So Broadcom, despite delivering the firmware in ROM, they need a mechanism to somehow update a firmware in a ROM.
ROM
the
patches.
Question is like, how do you do this? Like read-only memory, you cannot modify. But what you have on ARM, there is a flash patch unit. Mm-hmm. So it's like debug breakpoint, so to say, transparent. And these can override 4-byte chunks in the ROM. So transparently overwrite. This means like after you restart the chip, they are gone. But you write this to the flash patch unit, and then like at 4-byte offsets, you can override 4-byte chunks. And 4-byte is just enough memory to have a branch instruction. So usually what you would do, like somewhere in the ROM, you set like the flash patch unit, and then you set a branch link to somewhere in RAM, and RAM you can write to RAM.
Yeah. But what you're describing there, the ROM isn't getting loaded. They're not loading particular sections of that into RAM, correct? And then execute.
No, it's just like,
if I understand correctly, if you patch address, I don't know, 10 of the flash, when you go read address 10, it's actually just going to pull it from RAM kind of magically.
From the flash patch unit.
Yeah.
So you can override anything in ROM. Interestingly, this is something then used much later in Frankenstein. For example, you can override the memory fault handler. So if you would access an invalid address, you would get like the memory fault, and then you would know, okay, this address is not mapped. And by this, like by overwriting the memory fault handler, which is in the very beginning of the ROM, you can get a memory map of the chip.
Yeah, this is brilliant.
So this is like the level of stuff that you can overwrite in the firmware. So this is like really, really nice for debugging.
You're basically at the cellular level, as it were. Like,
yeah, but
Yeah.
how do you? So, as the reverse engineer, as a user, how do you actually get access to the flash patch unit? Is this something you just write this is Nexus's, right? So just write an Android app.
No. The flash patch unit, it's also, like I said, there's a write RAM handler. And also, I mean, it's called write RAM, but you can write like anywhere also to registers. And the flash patch unit is just a register. Like one of them is a bitmap. So 128-bit or 256-bit bitmap, depending on the chip version, where you say which slots are enabled. Then there is another memory area mapped where you have a table of the address and the 4-byte value that you overwrite, and that's it. So just by writing to RAM, you can also define this flash patch unit stuff.
Does Android not stop you from writing to these areas, or do you have to go in as a developer mode, or how do you actually?
So it's in the Bluetooth chip. So you have something it's called HCI, host controller interface. So if the phone is rooted, or on iOS, if the phone is jailbroken, then you can send those HCI commands. Or on Linux, you need root. So if you're root in some way, you can send a so-called HCI command, which is just implemented by the Bluetooth driver, and you can just send this to the chip. And each manufacturer has like different, vendor-specific HCI commands. But like the standard commands are like connect to another device, or like get this device address, etc.
Or patch the flash, or patch the ROM. I know Broadcom is not known for publicly documenting things. How did you find, or how did y'all find this unit?
So, back in 2016, Broadcom thought like we have too many customers in this like wireless division. So that is, how should I say, customer? Like if you have a small business and let's say you have, I don't know, fitness trackers or something, or cars, or I don't know what, like where you have not like hundreds of millions of chips that you produce, but just something like 50,000 chips. Then it's only a few chips, and Broadcom didn't like to support this, I think, or I would assume.
I could see that.
So, go ahead, finish your thought.
So it's just like a small amount of chips, and still the customer would say like, I need the following custom features for my product. So it's a lot of work handling small customers. And then they had this idea of, okay, overall they are still worth a lot of money, so let's sell our IoT division. So basically all legacy chips and all small customers were relabeled as IoT. So Broadcom sold the IoT division of the wireless stuff to Cypress.
Oh.
Which is now Infineon.
Which is now Infineon, but that happened later. I mean, but now the thing is, when Cypress acquired parts of Broadcom, they just went and published like the SDK and some of the older datasheets. And in the datasheets, you finally you see the write and read RAM commands. It's still not documented how this flash patch stuff and the patch RAM works, so they call it patch RAM or patch ROM or something. So it's not documented. But if you look into updates that they ship, then you can figure this out. And this is what Dennis did for his thesis, like poking around in the update mechanism. Yeah.
So Internal Blue is an easy way of accessing this,
exactly,
using this flash patch to do funny business with Bluetooth.
Yeah.
Cool.
Yeah, I was just going to go back to Broadcom specifically. Their model is if they're not making enough volume, not that they don't have enough customers, which kind of leads into what you were saying, Jiska, which is if they have lots of customers, that's great. But what they want to sell is a lot of chips.
Yeah.
And they want to make it super easy. Yeah.
I think customers are companies in this case,
Very,
right?
very
Yeah.
first tier, like hyper first tier. Otherwise, they just divest. And you can see it in how they were supporting Android devices and IoT. And
Yeah, I didn't know
there's
the
some
whole
other
Cypress
ones that are
thing.
coming up too.
This is
that
all
they're
news to
divesting.
me.
Yeah.
But
cool.
interestingly, so like the customers that Broadcom kept were like, for example, Apple and Samsung. So they have really large amounts of chips. So this is yet another issue, right? So you could get the SDK and even from the SDK a symbol leak from the Cypress chips.
Yeah.
But the main devices but the interesting targets like iPhones, which also have those chips, they have a code base that diverged a bit. So Cypress and Broadcom are like developing the stuff independently. They also patch bugs independently. They did independent testing. So
yeah, no, these are big enough customers that everything could be custom and like they make enough money.
But as far as I can tell, it feels like Apple ends up driving a lot of the innovation for these companies. So for Nordic, Broadcom, like they end up like I believe the whole Bluetooth audio thing was probably being driven by Apple. I'm sure Alvaro has plenty to not say about this.
I don't know what you're talking about.
Yeah, I mean, I think in Bluetooth 5.2 there was BLE audio introduced, and I think various vendors already had this. Like the AirPods that I'm using right now, they have a BLE audio something, and I think also Bose with a Qualcomm chip inside, they had BLE audio. So it was already there to some extent, but just made it in the specification much later.
Yeah. It's like implement first, standardize later. Sure.
No, there's another step in between. File all the patents, then
Yeah.
All right. So we were talking about internal blue, and you also mentioned Frankenstein.
Yeah.
What is that?
Frankenstein is yet another project, also a student project. So during my work on internal blue, I found one bug in an LMP handler, so link management protocol, where they had implemented a custom command and then they forgot a bounce check. So, and it was jumping into yet another handler. So it was not direct code execution, but I could go from one handler into another handler that I shouldn't, including passing arguments, but not always custom arguments. So because the arguments of both handlers are like in a different format. So it's a bit weird what constraints you have in executing code in the wrong handler. So back then I did a little bit of emulation. Like I got a snapshot from the RAM at the point when I was in the LMP handler that got the packet. And I just did a bit of emulation to see like in which addresses would I end up, because I did not have any symbols back then. I had not found the Cypress leak back then. So, I was very blind in this firmware, and I was just checking like, okay, cool, there's like one command that I can execute that writes to a very high memory address, and I found out that this enables like the test mode on the device where you can make it send weird stuff on weird frequencies, for example. So basically disable the chip and also use it for jamming. Like over the air, you can turn another Broadcom device into a jammer.
Oh, wow. Oh, over the air?
Yeah.
Oh, that's fantastic. Yeah, because I know the Nordic chips have like a constant signal mode and stuff where it just sends out a sine wave, which is used for our RF certification testing. And yeah, that's wow. I didn't know you could do that from a different device.
So
yeah, I mean that was the security issue in there, right? So
you don't need to be root on your device. You could just tell someone else's device to go nuts. Wow. You had a question, Jen?
So this information is really interesting, but I'm just kind of wondering then, like I'm looking through the project itself, and of course this will be all in the show notes. I'm just kind of wondering, are there any prerequisites if I wanted to set this up for my project? Let's say I have
What,
a
the
target.
internal blue?
No, Frankenstein.
Yeah. So Frankenstein is, it's an emulator, so it runs independently. But yeah, so I started some emulation, but independent from Frankenstein, just to explore this one vulnerability. And then Jan came up with the idea to fully emulate the firmware and really the handlers, including thread switches and everything, to search for more bugs. Because if I could spot a bug just during manual reverse engineering and exploit it with basic understanding, then emulation might find even cooler bugs.
Yeah. And are you emulating like an entire Android OS or just the Cypress Broadcom chip?
Only the chip. And then I said it has this HCI interface.
Okay, yeah.
And actually, if you emulate the chip, so with Frankenstein, you can emulate the Bluetooth chip. And then on Linux, you can use BT attach. And then it would show as a serial device and be a Bluetooth chip. So if you are on a Linux system and attach a Frankenstein emulated chip to Linux, so it's just serial device, BT attached, that's it.
Oh, cool.
And then you scan for devices, and then you would get random scan results, for example, because they come from the fuzzer.
Just memory, yeah. And is this using like QEMU or something, or how do you emulate one of these things?
Yeah, it's QEMU.
Oh, cool. Huh. That's really neat.
So yeah, that just works on Linux. I mean, if you can get QEMU running on Android, then you might also be able to attach it. I think it should run on the same host just for speed constraints. So I don't know if you would like emulate in QEMU on Linux and then forward this over ADB it's probably too slow.
Yeah. Bluetooth has some tight timing constraints usually.
Yeah.
That's really cool. All right. So next up on our list of questions, we have Polypus, I think. Is this another reverse engineering tool, I assume?
So yeah, there's another student also called Jan, but different Jan. So I tend to collect like students with similar names.
Collecting students. That's a good title.
And so from the symbol leaks from the Cypress SDK and also some other versions, we had the issue like suddenly you have like 10 different Bluetooth firmwares or 20 different Bluetooth firmwares, and all of them are somewhat similar, and you want to diff through them. And if you diff a raw binary firmware, then you have the issue that the disassembler often does not find stuff. So it's ARM assembly, and in ARM assembly, you have the issue that almost everything is a valid instruction. So you have, given a random input, that this random input is a valid instruction. I think valid 2 or 4 byte instruction. The random sequence that you have
versus the regular instruction.
Yeah, it's
I guess
like
are
99%.
Yeah. I guess my question is, are you indicting ARM for having way too many instructions? Is that what you're saying? is that
I mean, indirectly, and like because everything is an instruction in ARM, the disassembler often fails in identifying instructions.
Yeah, because you don't know where to start, right? You just have to align it. I guess the vector table is usually good for that, though, right?
Yeah, but most stuff is not found via the vector tables in the Bluetooth firmware. So,
okay.
Because it's too complex, and then there is like an operating system with thread switches and stuff goes like indirectly through task list and thread list and everything. And this is something that is like way too dynamic to find it via the interrupt tables.
So how does it work then? Does it try to disassemble at different places and see what makes more sense, or?
No. So you have the issue like you cannot really disassemble it, or like the disassembler fails and then bindiff would fail. So if you apply bindiff to something where the disassembler fails, Yeah, it's super super complicated, right? So you cannot really bin diff because you
Yeah.
cannot disassemble,
Uh,
and
this is
yeah,
what it sounds like to me, is that, yeah, you could try, systematically going and picking something and seeing whether it decodes, and that could just take a
yeah,
really long time.
But yeah, that's brute
Yeah,
forcing.
it just sounds like it's one of those things that it's different for every single project, so there's not like a known established procedure for doing that. Would that be accurate?
yeah. I mean, there is, for example, there's a thumbs up. So that's not
Mhm.
a project by us, but you can Google thumbs up. So what they do is they go into like everything that IDA found and then try to learn like for those compiler settings that were used in a project. I mean, you don't know it for a reverse engineered project what compiler settings have been
Yeah.
used, but it tries to learn how functions start and then it
Mhm.
tries to find more function starts. But this is not what the polypios project is about, because this is like still fixing the disassembler, still not fully fixing the disassembler. So polypios instead uses the fact that we had symbol leaks from something like 3 or 4 dev kits,
Mm.
um, and all with the same function names. So you could actually go and say, like, we have 2 functions that, let's say we have memcopy twice.
Yeah.
Mhm.
Um, and now you could make a function signature by like removing the branch link instruction or something. But what polypios does instead is it's using like both memcopies, puts them on top of each other. And now if you have a branch instruction, for example, it would go to like a different address. So it would be different. And then it just marks out those bytes of the branch instruction, but leaves everything else there for a pattern to match. So all bytes that are equal in both memcopies, it would take and then say, okay, this is now my signature for a memcopy, or like my byte sequence
Yeah.
for a memcopy, and then you can search it in the others.
So it sounds like this can cut down a lot of stuff as long as you kind of already know something about the platform that
Mm-hmm.
you're working on. It also seems like you're probably, your best bet is to at least know what the chip set is to at least get started to where it's
Which you probably
probably.
will know, right? Like it's probably rare
Yeah.
that.
I don't know. Like, it feels like if you end up with any products that are from a Chinese vendor, you're less
Oh,
likely to know.
Yeah.
but I guess you mentioned you're mostly working with like some Nexus devices in iOS,
Mm-hmm.
because like those you'll know.
Yeah, but you don't know the chipset of the Bluetooth chip. I mean, you know, like the main
Oh,
CPU, but you don't know
I see. Yeah.
yeah, what's running on the Bluetooth chip. Could be different. I mean, no matter if you have like an Intel MacBook or an ARM MacBook, the Bluetooth chip from Broadcom is always ARM.
Mhm.
Are
Yeah,
there
and I
any
guess
chips that you've run into that aren't ARM these days? I can't think of anything.
So I mean,
Unless they're super
uh,
tiny chips, like really
yeah.
old.
So Intel has a baseband, and they used ARM, and they also switched back to ARM. But they had in between, like the ICE 18 series, they had Intel.
of
So
course.
really x86
Yeah.
baseband,
Wow.
and then there's Extensor being used in a couple of chips. I think that's the case for ESP32 is, I think, Extensor. Also parts of the Intel chips, like it's also combined with Extensor stuff. And then for Qualcomm, they have Hexagon. You would also find some chips that are using, I think, ARC or something. So there's quite some variety in wireless chips. So probably 80% or 70% ARM, but not all
Wow.
of them.
Yeah, and I guess it's a good segue to you mentioned that now you've been kind of working a lot on iOS devices,
Yeah.
um, and I guess this is one of the reasons, right? That it's like more uniform, I guess, environment.
Yeah, also.
Or I don't know
Yeah.
why would you say that's you've gone more on that side of things? I guess.
So the thing is, like, if you do wireless, you want to have the most recent chips and to look into them. And the issue is, so you can buy dev kits from Cypress. And yes, the ROM would have a build date like 2018, 2019, something quite recent. but it would not really have all those customer-specific updates. And also Broadcom did some internal security testing with internal bugs found and also internal performance optimization, etc. They never sent this to Cypress. So at least from what the code looks like, I mean, I cannot tell for sure how the internal process it is, but I assume like Broadcom did a lot of things that never made it into Cypress after selling their IoT stuff to Cypress. So if you want to have a look like into the most recent Broadcom Bluetooth chip, then you have to either buy an iPhone or a Samsung Galaxy S series. Over here in Europe, at least they have Broadcom chips, not worldwide, but in many devices. Yeah. So I ended up using iPhones for research just for the fact that they had like the most recent Bluetooth chip from Broadcom.
And I guess I'm curious then, is there any difficulties working with an iOS product? Like, are there any, like, just, I guess, when I think of iOS and working with it, there's usually some sort of artificial money boundary. Not only do the products cost more, but sometimes to develop with the device and put your own app on it, you have to pay money to do that.
Yeah,
so I'm just kind of wondering.
So shame on me, but I still don't have a real Apple developer account because it costs $100 a year, and I don't want to give that money to Apple. You can have a free developer account, which is but the issue is then when
did that start?
A few years ago.
Yeah, just if you use Xcode. But the issue is then the signature of the app will just be valid for 7 days, and you cannot really put something in Apple's App Store. But we have a university account then again, which we can use to put stuff on the App Store. So I personally don't need any developer account. But yeah, I think the larger issue is like to jailbreak iPhones. So
the never-ending battle.
Luckily, there's check-rain now, but when we started, so there's yet another Dennis.
Sorry? What's check-rain? For our audience, what's check-rain?
Check-rain is a jailbreak that is in the iPhone boot ROM. Mm-hmm. So Apple cannot patch it. And everything up to the iPhone 8 and X, you can just always jailbreak via the USB and bootloader bug. Mm-hmm. So they stay jailbreakable. And before it was like for any iOS update, you would need to wait until someone finds a bug in the iOS update. Mm-hmm. But because
before
it's in
the bootloader,
it's now just permanent.
Yeah.
So yeah, and like Dennis, yet another Dennis, he ported internal Blue to iOS. So that was really, really nice to just work a bit with the chip.
I have to say, keeping track of the names in your story.
So by now we have Dennis. two Dennis and 2 Jans. Yeah.
Yeah. Thank you for getting everyone up to date on the count. Okay, as you were saying, go ahead. Yet another Dennis.
Yeah. So he ported internal Blue to iOS, and he also wrote a fuzzer for the Bluetooth daemon on iOS, so Toothpicker.
Toothpicker. That's a good one.
Yeah. So that's also on GitHub if you want to check out. And I like a week ago, I just ported symbols to the most recent iOS version, so it still works on iOS 14.8. Pretty nice for just some fuzzing in the Bluetooth process in user space. Yeah, basically the fact that just like the most recent Bluetooth chips are on iOS devices moved me to working with iOS. And I really learned a lot from the students who spent like all of them half a year for a thesis on those topics, or sometimes even a bit more, depending on like if you add time that they worked before with certain tools, etc. Or like we also have projects at university, so you can do a 6 CP project in advance before doing a thesis, so you can also extend the time a bit. As I said, I also tend to like then build a bit based on those projects.
Yeah.
So
this is kind of a slightly sidetracked, but it seems like there's a lot of really cool security research at this university. This is This is
Is
pretty
it,
nice.
yeah, is it known? Is it specifically known for this type of security research, or?
Yeah, at least in Germany. So we have an IT security master.
Mm-hmm.
So people can specifically study security with crypto applications, protocols, everything.
Nice.
That's really cool. We had to study electrical engineering.
Honestly, electrical and computer engineering are depending on what schools you go to, that's the closest you're ever going to get to even broaching this.
Yeah.
It's not even computer science.
Well, no, this is great though, because now you have students that are spending 6 months working on a very specific topic, right?
Yeah.
Like actually getting credit or even paid to do it, which is like super cool. And then it's public information, right? Because you could be paid to do it and then sell it to NSO, and it's like not cool.
Are you suggesting that people are like selling these these things?
I'm sure there's lots of people doing the exact same stuff, but selling it instead of sharing, publishing it.
Yeah. So okay, so iOS. I guess as somebody who doesn't like iOS very much. I also have an iPhone, but that's neither here nor there.
You can have it and not like it. That's fine.
I know. I'm still I still vaguely like Android better, but like, man, that just a pile of shit. Anyway, don't tell people that I said that. What are starting out on iOS? What should our audience know about it? I mean, not using it, but I mean, if they're trying to like break into the phone, if they're trying to like do any sort of security research, what are some things that you found were annoying or things that you had to spend?
Or useful?
Yeah. Tell us some tips and tricks.
So like the first thing is probably get a cheap iPhone, just a used one, refurbished. Don't use like your private iPhone because sometimes something breaks and then you have to restore. Also use an iPhone that supports check rain. So that means an iPhone 6S or newer, not the 6, but the 6S.
Mm-hmm.
iOS 15 is not yet supported by check rain, so you have to stay at iOS 14.8 or lower.
Mm-hmm.
Okay.
Which that came out like this week, so
yeah,
hopefully.
Yeah, but the issue
darn you for not being on top of this. I need the latest hotness, and I need a jailbroke.
We are on iOS 15.1 beta already, but the issue is that Apple stopped signing firmware updates or like iOS updates for too long. So usually, so as long as something is signed, which you can check on ipsw.me, you can downgrade the firmware on an iPhone or the iOS version, which you can still do today, I think. So 14.8 is, I think, still signed.
Using check rain, though.
Using check rain, yeah. But probably in like 1 or 2 weeks or something, this is no longer being signed. And then you need to double check that like the iPhone that you find on eBay is still having iOS 14 point something.
Yeah. Wow.
Is that a result of the security thing that happened a couple weeks ago where everyone had to update every single iOS
that was 0.8.
Yeah, it does not really have to do with this. So Apple just signs updates for a limited time. Mm-hmm. And I think like since half a year or something, they got a bit more aggressive. Like before you could get a signed version from an outdated iOS update like almost a month or something. But now they are really down to a week or 1.5 weeks of signing older iOS versions.
Oh, okay.
Yeah, Thanks it's good for security, but for research.
Yeah. So yeah, you might lose the data on the device, etc. So that's why you just buy a separate one. But if you buy something like a refurbished iPhone 7 or 8, they are really cheap, like $100 or something. I mean, it's not super cheap, but it's okay.
It's cheaper than a dev kit, right? For like a Broadcom, if you could even get one.
Yeah. The Cypress dev kit is just $50, but close. Yeah.
Yeah.
Right.
So okay, so you got a jailbroken iPhone, and then I think Natalie mentioned Frida, but I know this connects with iOS. Like, how does it work? Like, what is it?
Yeah. So Frida, I mean, how does it work? So overall, basically, you can like write hooks that when the function is executed, like either on enter or on exit or something, you modify the code before the actual function is being executed, or you can even overwrite the full function. So this is what Frida does. Now the question is a bit more like, how does it work?
Yeah.
So as of now, it only supports stuff in user space. So for the kernel, there is something different. It's called XNUSpy. But everything that's interesting in Bluetooth, I would say, is implemented in user space in the Bluetooth daemon. I mean, there's still like some kernel drivers, but all the super weird Apple protocols, all the proprietary stuff is usually implemented in the Bluetooth daemon. And then with Frida, you can just write a hook and modify the Bluetooth daemon. You still need to reverse engineer it. So you need to load the Bluetooth daemon into IDA and figure out where the functions are that you want to overwrite. But for example, something that you can do is you can intercept, like, let's say, the music that is being played. So I did this on the AirPods, for example. So you can just here and there flip some bytes in the communication or bits. And then you would, for example, hear some audio noise and cracks. I mean, that's a very basic fuzzer, not even injecting something. It's just like flip bits and bytes.
Yeah.
But you get like an audio effect that you immediately notice. And this is stuff that you can do in the Bluetooth daemon. And now if you would hook into more complex protocols that have more state or inject messages on purpose, etc., then you can even do fuzzing.
And is Frida run on the device itself, or is this something you
Yeah.
tether? Okay.
I mean, half and half. So you have the Frida server, which runs on the device. And you can also just like run everything on the iOS device for performance reasons. But for developing, you usually would have a Frida client that connects over USB to the daemon. And then like on macOS or Linux as a host, it doesn't matter. You can program stuff on the Bluetooth daemon. Now, the thing is, Frida, like on the iOS device, attaches to the Bluetooth daemon, similar to a debugger.
Yeah.
So it's basically like you would have a debugger or debugger setup, but Frida has a couple of additional stuff that really makes development easier. So, for example, on iOS, you have some native function or like library functions that are exported. So that, for example, if you have like a driver library or something, or a certain, I mean, there's a ton of libraries there. They export symbols, or if there's something in Objective-C, the Objective-C API is like leaking certain symbols, and all the stuff that is there being exported, you can use the symbols in Frida to make code readable.
Yeah.
So, for example, let's say I'm somewhere in the Bluetooth daemon. I just know like this function is being called. It has like a logging statement that I see in the syslog, and I want to find out what is happening. Then I just hook into this with Frida, and then I can say I want a backtrace. And even from this backtrace for this thread, I can say, and now add all the debug symbols that you have. And then you would get a backtrace with all the symbols that it finds. And I mean, in the Bluetooth daemon, there is not that many exported symbols, but all the libraries that the Bluetooth daemon is using, they have symbols. So you get something pretty readable.
That's nice. Yeah, no, I wish
I'm
I
trying
had
to
this for
envision
some of my
this. Yeah.
embedded stuff.
So I guess.
Well, also iOS is Objective-C and Swift, right? Which like still has a lot of the function, the names of stuff there.
Yeah.
I think for me, listening to this, because I haven't done any type of debugging on iOS.
Yeah.
I'm trying to visualize what this is, what those steps look like. Is it like just
you could do LLDB
console,
like,
or
it's a console. So you can basically you say Frida and then -U for like use a USB device. And then I think -- no pause or something so that it doesn't like stop. And you can also attach a script, which is in JavaScript.
Right.
I mean, you can also compile C code and then run locally on the device. But for debugging, it's just like JavaScript, which is easier for some live coding, because if you attach a script, that's also a nice function of Frida. So if I'm on macOS and I want to do something on an iPhone, I have a script open in an editor, and every time I hit the save button, I have a file system action, and the Frida client notices this and then is reloading the script. So I can do like live coding, have the console open and print in like the Frida console. I would see my print statements and can do live editing in the script and see like everything live happening like that in my code and then the print from the Frida console.
It's like continuous testing, but on a small scale, not like a big backend.
And while reversing, which is huge, right?
Yeah.
Like having to compile, reload, like manually would take forever.
Oh, yeah.
And also awesome. In the Frida console, like I have the script in an editor, but in the Frida console, I can also code. So if my Frida script is using like some classes and exports, then I can tab complete on the stuff that I have in my script. And additionally, the Frida console knows like some of the debug symbols or some of the Objective-C API stuff. So I can also tab complete Objective-C names or Objective-C classes in the console. So it really feels like live scripting.
Yeah. No, the whole Objective-C makes things easier, I think, for the reversing stuff versus no
you mean
symbols.
Not just writing the code, the reversing of the
writing
code.
Objective-C is not as much fun, but
yeah.
I feel like there's a story there, Alvaro, but we don't have time for that.
Oh, it's yes. I can another time, perhaps.
Yeah, another time.
Yeah.
And I forget if this was what was used for like fuzzing SMS stuff, or was that a different?
Also. So there is like Toothpicker built by Dennis, so Dennis number 2. So you can build a fuzzer with this. He also built a second framework, it's called fpicker, which is a bit more generic. So the fpicker is similar to Toothpicker, but just more of a fuzzing framework for similar fuzzers, and also integrates AFL++ instead of using Radamser for mutations.
Are those built on top of Frida, or are they separate?
All on top of Frida.
Oh, cool. Okay. Dennis too.
So yeah, Frida enabled fuzzers. So I mean, like Frida has everything that you need for fuzzing. So the first thing that you need for fuzzing is call a function with custom inputs. So this is already built into Frida. And then the second thing that is nice to have is some sort of feedback. So you could either hook functions, like if you are fuzzing a protocol, you can of course hook what are the replies that you get if you send something. But you could also start other things. And Frida has a mode where it has, it's called Stalker, and the Stalker can collect coverage in basic blocks or in functions. So you can even collect coverage, which is all you need for a fuzzer.
And coverage is which functions are getting called how many times, basically?
Yeah, so you can make it function level. So you can get like which function has been called, in which order, how many times. But you can also get basic blocks. And a basic block is like code that is executed in a sequence. So I have like several move instructions, load instructions. They are always in a sequence. Then I have a branch instruction, which goes somewhere else. And like this is where the basic block ends, because execution can go in 2 directions. So, and every time, so basically in C code, like an if statement or a switch case statement, every time you have a decision that is non-linear, then you start a new basic block. And then you know, like really every line of code that has been executed and not just a function.
Yeah, no, so it feels like Frida is this massive, like you can do so much on top of Frida. Like that's the part I think I didn't quite understand, because everyone's talking about Frida and I'm like, I guess you can hook things, but then that enables like a whole other kind of level of things to implement on top.
So is there a big developer network or? to add things to Frida then, such as Ice Picker and F Picker?
Yeah,
and
so
on?
there's like one very large project that's called Objection. And the Frida objection thing, I have to say I never used objection because it's too many layers above the stuff that I usually need. But like the standard thing to use objection for is to bypass like certificate pinning in TLS or SSL and in apps. And there's another thing with that. So on iOS, except for like stuff in the system image, the applications that you can download on the App Store, they are encrypted, but not during runtime. And then there is like a Frida tool with that you can dump the application while it's being executed. So without encryption.
So I guess for listeners who don't realize how big a deal the cert pinning removal is, like if you want to reverse engineer the protocol between an app and their servers, it's usually using HTTPS, and then if you try to remove the certificate, it's gonna be like, no. If you give it a fake certificate, it's still not gonna let you do it. So getting rid of pinning lets you put your own little malicious cert and sniff all the things.
Yeah.
All the things.
Yeah, I know that this is, I've run into issues in the past where before I would just set up like a Raspberry Pi as an access point, and then I would have my phone or some IoT thing connect to it, and then I would, sniff all the traffic. But yeah, once HTTPS came along for everything, that became a little trickier.
Yeah. Well, I think more the broad adoption of it.
And yeah. But anyway, so lots of research to do on Frida, because this sounds really cool, and I need to get an older phone.
Yeah, and also the cool thing there is that because so many libraries are exporting symbols, you can write hooks that are independent from the iOS version. So if I figure out like if it's like Objective-C or a library that has like some symbol that Frida can access, then I can just say like whenever, let's say there's over the normal API, like a URL or a file being opened or read or whatsoever, then you can hook this thing in a generic way, and this hook will work as long as this API is not changed, which usually is the case over a lot of iOS versions.
Yeah, that's really cool.
Yeah.
And I don't know if this connects at all, but did you use Frida stuff to do some of the AirPod and AirTag kind of reversing, or can you tell us a little bit more about that?
Yeah. So the AirTag. So that's something that I had on the internet where I was like playing the AirTechno. I mean, it looks like a fun video, like just you play a custom sound on the AirTag, but there's a lot of reverse engineering behind this. So there is stack smashing.
Yeah, so break it down for us. We will put these in the show notes.
We're going to have links to all the things.
Yeah, so stack smashing, he glitched the AirTags, and in his DEF CON talk, he already had like some rickroll or something just playing on the AirTag. Like what he did was replacing the sound samples in the firmware, because he glitched the firmware, so he could also flash a new firmware, and this firmware had different sound samples. So when he was then playing like the lost sound or something, it would just play the custom music that is now on the AirTag. But this is like the basic understanding that later on was needed for the thing that you saw in the video. So it's basically two parts of reverse engineering. So one part is what Plonk did. So he analyzed the NRF firmware and found the handler for playing a sound command. So when I lose my AirTag or when I turn on my AirTag or something, there are different play sound commands, or like, I mean, turning on is not over BLE, so it's still a handler like this, but being addressed differently. But everything via Bluetooth is being addressed via a handler. And he found where this handler is, so he found out what the format is that you need to pass to it. And the format is like, there are different pre-programmed sound on the AirTag. So the sound sequence that you want to play of the pre-programmed sound then how often you want to repeat it, then with which offset within the sound you want to play it, and last one, I don't know. So something like this, right? So there's like four four different things. I think the pause is the last one, like the pause to the next sequence, and you can put multiple of those behind each other. And this precise format is like the part that Plonk found out. And on the end that I did with Frida on iOS, I found out how to schedule like a task or a command on the AirTag. And so how to actually play something custom.
So it's basically you designed or hacked in a sequencer, like a music sequencer, effectively.
Yeah, and I just play like something on the sequencer, so to say, and I send this over Bluetooth, so you don't need to open the AirTag. But now the cool thing is, so now we are back to all this Objective-C stuff.
Because that's where we want to be.
Yeah.
No. Go ahead.
Yeah, but so it's Objective-C, and it's in the location daemon, because I mean AirTags are related to locations, so the location daemon has the sound handler as well. And basically on an AirTag you can schedule a task, and the location daemon, because it's an Objective-C, defines all the names of the tasks that you can execute. Like there is a play sound sequence task, and then there is also the play unauthorized sound, which you can do if you find an AirTag that is not yours, then you can play a sound on it.
Oh, yeah.
Yeah, and this stuff, I mean, it's like in the list of the tasks that you can execute.
Yeah.
But usually I would have to reverse engineer the Bluetooth protocol and how it works.
Yeah.
But with the tasks, I can just call the task, and for the play sound sequence, I have to pass the sound sequence that I'm going to play, but there are also many tasks for that I don't have to pass any commands.
Yeah. I have a question. So you said that you just referenced that there's a unauthorized handler, like play handler. Were you ever able to figure out what feature that was tied to? Like why?
That's probably like if somebody puts an AirTag on you that's not yours, your phone will tell you after a while that this thing is following you. Is that it?
Yeah, there's a couple of features there. So first of all, if you find someone else's AirTag, then you want to know, like, is this AirTag, or like you can play a sequence on this, but it has a rate limit, so you cannot like play it arbitrarily often.
You can't jam, yeah.
Yeah, it is something. And then there's also privacy features, because someone could like put an AirTag in your jacket, and then the AirTag is following you. And this would be a bad thing, like to stalk someone via an AirTag.
Yep.
So if you have an iPhone and an AirTag that is not paired with your iPhone is following you for more than 8 hours, or a random time between 8 and 24 hours, you would see a notification.
Yeah, okay, but that one, yeah, so that's not the one that would play the unauthorized sound, but yes, that is a...
Yeah, I think also in addition, they added something that if the AirTag is currently not in range of its paired device, then after this time it would also start playing sounds or something.
Yeah, I guess in my head, like, okay, yeah, like being stalked, that's one thing, but playing a sound, or I don't see how that would benefit me, because it would be just like, get this off of me and then like leave. I don't know.
Yeah, but
I don't use any of these products, so.
Yeah, but I mean, they are super small. They could be attached to something that you do not see.
Like my car, yeah.
Yeah.
I have one on my bike.
Yeah. Also, I mean, I said, like, you can only do this on iOS, but a colleague of mine, Alex, he made together with a student, like, again, students, right? But they made an app for Android. How is it called? I just forgot it. Damn. But yeah, so there's I also retweeted it, so you would find it on my Twitter. But so basically the app tells you on Android that you have an AirTag nearby and you can like play the sound, and you get a map of AirTags around you that are currently not paired to iPhone. So as long as an AirTag is paired to an iPhone, it would not send anything.
Makes
I
sense.
mean, you are still there. It
Yeah.
doesn't need to do anything with location, but as soon as it's like losing the paired
Beeping.
iPhone, then it sends like all this, help, I'm here, please find me.
Find my owner, please.
But
I remember the name. It's called AirGuard.
Yeah.
So AirGuard is the app.
That makes sense.
And
AirGuard. Okay. Because I'm like thinking about this. I'm like, I don't own any of these, but if someone was tracking me, I feel like I'm kind of screwed in terms of
but you can walk to a building, I'm sure, and it's going to be full of AirTags. Just people are going to put them on keychains and like, or like your AirPods.
Yeah, there's
also have
I think it all.
features.
I guess the question is like, does this all tie into the Find My Device profiles?
Yep.
Yeah,
Yeah.
exactly. Yeah,
And-
every product has this now, whether they want it or not.
You mentioned Twitter, and I wanted to make sure I asked about that. But you and Stack Smashing, I don't know who started, but y'all host these kind of Twitter audio chats every once in a while, reverse engineering themed. How did that get started, and kind of how's that going?
So that was like Stack Smashing and me starting this. I'm not sure. I think it was like his idea, and we started on me and Names Clubhouse. So it was Clubhouse first, and then we tried Twitter Spaces and Discord and stuff. So we are just like switching platforms depending on like what is the best. And also it depends, like he's not there every time, but now there's also Domino who is like into fuzzing, and Plonk who is a lot into reverse engineering. So it just depends who hosts this, but we try to do this like every 1 or 2 weeks, depending on how busy we are.
And to find out, it's just follow y'all on Twitter, I guess, right?
Yeah.
I dropped in for one. I think I mentioned it in one of the last episodes, but it was a lot of fun to chat. Like it was very technical, like in a good way. Like people really nerding out over reverse engineering things. And it's
that's
like,
really great. Like you regularly get people who know much more about a topic than yourself. Like last time I was like, okay, so what is the difference between core graphics and image IO on iOS, because both is like somehow has been exploited, but like how is an image being parsed? What are the differences between the two libraries and stuff? And I was like, just like, I don't know. It just like has 0 days that are being exploited over, I don't know, maybe iMessage, right?
Yeah.
And someone jumped just in and explained like how that works, what is the difference between the two, etc.
Yeah, no, it's great, and because we like Jen and I here in Mountain View, we have the Mountain View Reverse Engineering Meetup, which is like once a month, and now it's mostly virtual, but not everyone has access to kind of like other reverse engineering
platforms,
kind of
meetups, socializing.
So I really like that y'all started something like that.
And I think the thing that's interesting here is that you had mentioned that you went to one of these, and then I was like, oh, that's what that thing is up at the top sometimes that I see on Twitter.
That it's like purple.
And I click on it and I listen to it. I don't think I'm getting nearly as engaging content as what you stumbled into, because the ones that I have on Hacker stuff,
this one was
not
great.
as engaging.
No, it was. It's also early on in the day for us, like US based folk, but I mean, that's it was 11 o'clock, middle of the day for me. It was perfect time to hop on and distract myself from work.
That's the difference. I'm like, I'm not an early waker.
That's your problem.
I swear to God, if I could strangle you.
maybe we should move away from Wednesdays, but somehow it just became the Wednesday at 8 p.m. German time, which happens to be in the morning, I think, for you.
11.
Yeah, for us it's like 11, I think. Yeah. Which, I thought was fine. But yeah, so I'm going to encourage more people to check those out.
Like for the lunch break or something.
Yeah. Or just,
There's lunch breaks? What is this you speak of?
That's the meeting that you have at 12.
Yeah, yes. They actually
There's no
scheduled
food
us.
at that lunch meeting.
Stop beating your desk.
I'm not
Take a
eating
break.
at lunch.
Oh no, that's worse. No, that's like I do not. We're getting way off the rails, but
We're way off the rails
I
here.
don't skip lunch. That is.
We could talk about this afterward. Even
yeah,
before COVID, I was not. So
yeah, we've covered so much. Like this is
very
amazing.
dense, very dense.
Yeah.
And I guarantee you we're going to need to spend some time making sure we have the right links.
Yeah, we've been typing some stuff on the side, but we might ask you a few like clarifications.
Yeah.
Is this what you meant? But yeah, I don't know if you have any other thing you wanted to mention before we close up.
Yeah, I think you covered like most of the Bluetooth related stuff. There's also, you mentioned it briefly, the thing with the ComCenter on iOS, which I fuzzed.
Yeah.
So I think this is not the best fuzzer I ever wrote, but the funniest fuzzer. So I think it's always hard to like visualize fuzzing. In most cases, fuzzing is just like, random inputs, and then you wait until you get a magic crash. And then you have to debug a crash. And if it's like an issue, or it's just like denial of service or exploitable.
Or it's just bad firmware altogether. Not related to anything you did.
Yeah. And most of the time, like fuzzing is not visual at all. But what I did on iOS is, so between the baseband chip and the daemon that does everything with telephony, etc. So this is called ComCenter. There is a protocol. It's called ARI, at least for the Intel chips. So ARI stands for Apple Remote Invocation. And this is the thing that I fuzzed, but like the direction from the chip to iOS. I mean, you can also fuzz the opposite direction, but this is not that visual. But if you fuzz it like from the chip to iOS, then the fun part is like you would receive phone calls, you would receive SMS, you would go online, offline. You would also get like these special warnings. So like if there is a flood or something, you usually get a warning on top of
the emergency alerts. Yes.
Yeah. And also if you have a SIM, then the SIM usually has like a menu. For example, if you want to add money to your phone.
Yeah.
And all this stuff is things that you can fuzz and that you would visually see while fuzzing.
Yeah, and I should say, you have a YouTube link to a presentation, right, for a conference? So we're going to link to that as well, because that was fun to see.
These are going to be very chock full. This will be a very informational.
Yeah, we're going to have
set
pretty
of
good show notes.
For those who typically don't read the show notes. It sounds like you're going to need to.
But we also, we've talked about all these cool tools, but I still going to ask you what are some of your favorite tools, just in general? Like we love asking people about tools. So,
I mean, we talked about Frida, and I have to say, I'm using Frida so much these days, even though it's just in user space, it's not in firmware. But like even the playing audio on the AirTag is like something I use Frida for. I don't write any own code anymore. I just re-instrument what is there with very, very bad JavaScript. But I mean, who cares? Yeah, it works.
Can I interject a question? What does good JavaScript look like then?
I mean,
does it look like Perl? What?
Oh no.
No, but the worst part about the type of JavaScript that you start writing when you use Frida is you write or you instrument Objective-C in JavaScript. So you combine two languages. And then sometimes you have stuff like it's not really in an object or something. And then you start using, for example, the ARM registers to go into something. So you combine like registers and stuff and Objective-C and stuff all in JavaScript.
That does sound pretty gnarly.
Okay, I think you won. You won. I like I'm used to seeing like in C you'll have like some intermix of C++ and assembly, like ARM assembly kind of intermix. Like but then you added that, you sprinkled that layer of JavaScript right there, and I was like, wow.
It's like
unexpected.
Yeah. I'm always surprised once my code works and runs.
Welcome to the club.
Yeah.
It's like I do this for a living, and I am also surprised.
Step
like,
back, because you may or may not
working?
be surprised either way.
Yeah. Awesome. Well, thank you so much for joining us here today. Where can people find you online, if you want them to find you, of course?
Yeah, on Twitter. Oh wow, my Twitter handle is Nerdine, NAHRDINE, I think.
We'll have a link to
We'll
it.
put it in the show notes.
Yeah. Yeah, it's hard to spell. It's like a pun, or like, how should I say it? So usually there would be like nerd, and like the German female version of it would be Nerdine or something like this.
Oh,
And
that makes
then
more sense.
I put an H into this because I also love sewing clothes and stuff, and so as a hobby. So this is a pun of all of this, but yeah, spelling this or pronouncing it English, it's forget about it.
Thank you for understanding. Our English pronunciations may be very much amiss.
Yeah.
So, Alvaro, where can people find you?
I'm on Twitter at Alvaro Prieto. It's just my name. But yeah, same with spellings. AlvaroP.com.
I can be found on Twitter at RebelBotGen. If you have comments or suggestions for the show, or maybe a new name for the show, who knows? You can find us on Twitter at unnamed_show, or you can hit us up on the comment form, which we look at every couple of years. It's full of hilarity, so write us something sassy. If you can't find us somehow, you can also go to unnamedre.com. Shout out to our Patreon supporters, which I'm amazed how much traffic, how much conversation that happens without us doing pretty much anything.
Oh, yeah. We have a Discord for Patreons and guests. So you're going to get an invite soon.
Yeah. You get an invite.
If you want to join us on there.
And we're always looking for people to give us reviews on your podcast app, whether that's on Stitcher, iTunes, or Spotify. Thank you so much, Jiska, for coming on and like pretty much schooling us on everything wireless. Yeah, there's just so much new stuff I now need to go look up and figure out JavaScript, which was not something I was expecting to ever have to do.
Yeah, thanks for having me. It was fun to talk about all those topics.
Absolutely.
Great. Yeah. Hey there, it's Jen. Thanks for listening. Just wanted to inform you that right after we recorded this, Jiska told us that she was going to be presenting at this year's Hardware I/O. So go check her out. Thanks, guys. You can find us on Twitter at unnamed show. Wait.
_show.
Let me try that again. A lot of
it's
edits.
Not like we're reading from a script or anything.
I am. This is what I have to work on.